Hello everyone, welcome to thaiyoutube.com.vn tutorial video. In this video, I'm going to show you how to configure the Smart BD driver. So first, let's have a look at some key features of our product. Get to this link as I have shown in the comment and see what the Smart BD driver can do. After get to the link in the comment, scroll down to the description over here, so you can find out on the functions as well as the characteristics of the driver, like it is able to try up to 1 kilowatt DC motors at 24 DC operating voltage. It is able to communicate with computer through the UART standard. There's a LED on the board so you can easily observe the operating state of the driver. The special thing is it has 3 exclusive operating modes, which I'm going to show you the details later. You can also use the driver as an edge bridge, which is controlled by either PWM or UART signal. And that is some information about the Smart BD driver. If you want to learn more about our product, feel free to contact us through the telephone number at the end of the page, or you can email us through this address. Okay, so let's jump to the main part. There are 2 things you have to repair before we get started. The first thing is the configuration software. You can find the link to download and install the software on our website. I'll put this link in the comment. The second thing is a USB to TTL cable, which is used to connect the driver and the computer. And don't forget to make sure your computer has already installed the cable's driver. If it has not, the cable won't work. You can find the link to download the cable here. I have downloaded the configuration software, so let's install it. So this is our program, but before turning it on, we have to connect the driver into the PC using the USB to TTL cable. After plugging the driver, turn on the configuration program. The default baud rate of the driver is 19,200. So don't touch this board or you will be unable to talk with the driver. Just to the COM port that you are using to connect to the driver. You can see I'm using port number 7 here. Click the connect button. Here in Modern Boss, you are able to configure between 4 operating modes of the driver: the position, one direction and one pulse mode, position encoder AB pulse mode, BD speed mode, and the bridge edge mode. In position, one direction and one pulse mode, the driver will control DC motor to travel a distance with the number of steps equal to the number of PWM pulse you apply to each PWM pin, but only if your BD factors are good enough. A motor step depends on your S factor. S equal 4 means one step includes 4 pulses from the encoder. Whenever the driver receives a PWM pulse from the microcontroller, it will drive the motor to travel the distance of 4 pulses of the encoder. You can adjust this factor to make the motor travel with smaller step or greater step. After adjust on the factors, click Save Value button to finish configuration. The driver response will appear at the number wheel box over here. I'll run demo of the BAD position, one direction and one pulse mode. In this mode, I use a STM32F4 mainboard to generate the BWM pulse, which is the control signal that we put in the control part of the driver. The mainboard is controlled by an HMI to generate control signal as I wish. This is the power supply of the DC motor. I'm using the 24 voltage battery. Connect the BWM generator to the B controlling port on the driver. Connect the encoder wire from the DC motor to the encoder port on the driver. Apply the power supply for the F4 mainboard. Okay, so choose the position mode. I'm using the 500 pulse per round encoder, and my gear is 19.2. This is the speed of the motor. Let's set it at about 50. Okay, so I want it to rotate forward for one round. Again, I will change the direction of the motor. Increase the round to 3 rounds. Backward, I will increase the speed of the motor to about 80. Forward. Okay, that's it. This mode is nearly the same as position, one direction and one pulse mode. It also has the PID value and the S factor to adjust. The only difference is your control signal. Instead of using a microcontroller to generate the PWM signal, we will use another encoder with the same pulse per round parameter as the one on DC motor to generate the control signal. In other words, the control motor 8 will imitate the movement of the encoder B. This mode is quite different from the position mode. First, choose your control signal from the select mode box. There are two types of signal that are available, the BWM pulse and the UART signal. The SPI signal is not usable at the present version. So if you are using the BWM signal from a microcontroller connected to the control port on the driver, in this area you need to fill in your motor's parameter. To me, I'm using the 14,000 max speed motor and the 500 pulse per round encoder. Make sure you fill in the exact parameter, because if these parameters are way too different from the real model you are using, the driver could be malfunction and make the motor run crazy. You can test the driver by connecting to the DC motor, fill in from 0 to 255 in the dial box, and click the Save Value button to see the motor run. If you want to change the direction of the model, fill in 0 or 1 in the up box and then click Save Value button again. The model will change its direction according to your number. If you are using the UART signal from the microcontroller connected to the UART port on the driver, but once you have chosen the UART signal and saved the value, you will have to connect the direction pin to ground to be able to recommunicate with the computer again. While using the UART signal, you should know the valid data frame, which is sent to the driver as follows. A data frame consists of 3 bytes. Byte 1 includes 1 direction bit and 7 address bits. You can choose your own address bit here, or leave it at default. Byte 2 value varies from 0 to 255 in decimal, which is the speed of the model from 0 to the max speed that you fill in the speed round per minute box. Byte 3 is reserved and have to be 0 SFF. The other parameters are the same as the PWM control signal. Okay, so I'm turning on the configuration program. You can see I'm using the COM number 7 here. Click connect. The mode is BD speed and the control signal is PWM pulse. My model's parameters are 14,000 round per minute of the max speed and 500 pulse per round of the encoder. Okay, so let's test about 50. You can see the model is running kind of slow. Let's increase it onto 100. $150. $200. Max speed. You see, if I increase the number more than 255, the model will have the same speed. Let's change the direction of the model. Let's make it slow to see the direction of the model. Okay, so that's it. That's how you test the BD speed mode of the driver. X-Bridge mode operation is like an L298 model. Use this one if your application doesn't need the precision of speed and position. Like BD speed mode, there are 2 types of control signals that are available, the PWM pulse and the UART signal. If you choose the PWM signal, click Save Value button and connect the PWM generator to the driver's control port. If you are using the UART signal, connect the controller to driver's UART port. Choose your address and click the Save Value button. And once again, remember to connect direction pin to ground to reconnect to computer if you have chosen the UART control signal. The data frame sent to driver from the controller were explained at the BAD speed mode, and they are exactly the same. Thanks for watching.